Okay, so let's try a little example / quiz problem here. By the way, this is number 14 in 18.3 and a little extra that I added for fun. So, you need to find a potential function for f, which is 2xy comma x squared plus 8y cubed. So, what do you look at that and think? Okay, so you think, all right, this is the partial of something dx, and this is the partial of something dy. Okay, or you can calculate the curl and get 0. That'll tell you that it probably is conservative. You should check the domain, right? The domain on this is all real numbers, and it has continuous partials. The domain on that is all real x and y's, and it has continuous partials. So you know this is conservative.
Did you do your homework?
But what is it the derivative of? Yeah, now you need to go find out. So what did you x differentiate to get 2xy?
Yeah, x squared y plus y did was g of y.
So you might think, okay, if I anti-differentiate 2xy with respect to x, I get x squared y plus a constant, right?
Yeah.
Plus maybe some function h of y. And then if you anti-differentiate the other bit here, right, you find out that your question mark of x and y is maybe, what do you get when you y integrate that?
X squared y plus 2y cubed, or to the fourth.
X squared y plus 2y to the fourth. And then what? What else should you have there?
H of x. Plus h of x.
Plus maybe some constant, which could be like g of x or something.
Yeah. Oh, okay.
Right? Okay, so now you just go through and match pieces, right?
Yep.
Okay, so what do you got for sure?
X squared of y matched.
Okay, these guys match up. That's nice.
H of y and 2y to the fourth match up. Or can match up.
Those can match, right?
And g of x can be 0.
Yeah.
And g of x could be 0. So a potential function, right? Not the only possible potential function, but a potential function would be question mark of x and y is x squared y plus, what else did you need?
2y to the 4th.
A 2y to the fourth.
Bare minimum.
We don't need a constant, right? Because potentially.
Yeah, and you don't need a constant because this is a potential function. Another potential function is this thing plus 17 halves
Yeah. Okay.
times the log of 7. Right, like who cares? You could add a constant to this if you want to, you do not have to.
Because you can't add it if you
No, so that's the answer to the question in the book. But then the rest of the question is, so how do you use it to evaluate a line integral over a curve that goes from 0, 0 to 1, 0 to 1, 1? No. So why can't you apply Green's to this?
It's not a oval or any of the shapes that it
Not a closed loop.
It's not.
Yeah, it's not a closed loop, right? It goes from 0, 0 to 1, 1 and stops there. I don't know what it means to orient that counterclockwise or clockwise, right? Because it just goes like...
I think we're all.
Right? It needs to be closed and simple. This is not closed. Bummer. It is piecewise smooth, though. Okay, so how do you actually do this? What do you do?
So, like, all the way plug it in until I the normal line.
Yeah, so you could go through the whole line integral rigmarole, or you could use the...
You could think like a physicist and just calculate the difference in potential.
Yeah. Or you could think like a physicist.
I did it the stupid way.
So you could do the fundamental theorem of line integrals, right? Which says if you can calculate an antiderivative, right, a potential function, you could just evaluate the potential function at the ends and subtract. Right? So you can just do question mark of 1, 1 minus question mark of 0, 0.
Equals 3.
And you get,
I did the wrong F.
3.
so you get 1 squared times 1 is 1 plus 2 minus
0 plus 0.
0 plus 0.
That equals 3.
Cool. Equals 3.
Well,
So,
Or you can try the whole line integral rigmarole. If you were going to try the line integral, right, you should be integrating
from 0 to 1.
probably from 0 to 1, right? From t is 0 to t is 1, dt. And then what should go in here? Yeah, so you need the vector field itself, right? This guy should be f evaluated at r of t. So you need to go get your function f and evaluate at t cubed comma t squared. So you're going to get 2t to the 5th comma
T to the 6th.
t to the 6th plus 8t to the 6th.
So,
you can put those together.
Yeah, so you can collapse some like terms. And then you're going to need to dot product this with, what should this guy be?
Prime of RT.
Yeah, that should be r prime of t, right? Which is going to be 3t squared comma 2t.
let's see.
And then you could execute this whole jazz, right? So what's the price you pay for not noticing the fundamental theorem of line integrals? Yeah, a bunch of frickin' Calc 1.
You forgot to actually.
Right?
integrate. That was,
Cool, cool.
T2.
Is it the end of the world if you have to do a bunch of Calc 1?
Feels like it.
Hopefully not. Right? Like, it's not that bad. You can do it. I promise you guys can do that. What are you going to get out of this thing? 3. You should get 3. Cool? Questions, Steels?
That's fine.
Just